All right, so today we're starting chapter 8. We're in section 8.1, relations and functions. Okay. We'll talk about the difference between the two of them. They are essentially the same thing as far as they both consist of sets of ordered pairs, except there's just one additional rule for a function. All right, so here's what you need to know about a relation. A series, okay, so this is an important word. Really, the whole thing is important. A series of ordered pairs form a relation. So if I say a series of ordered pairs, does that mean one? No, it means multiple sets of ordered pairs. Does everybody remember what an ordered pair is? Okay, so an ordered pair is when you group, let's say, like 3 and 4. Okay, and then you graph this point on a graph. So 3 is my x value or my y value? Anybody remember? That's my x value. It tells me that I need to go right on the x-axis 3 places. And then 4 is my y value, and that tells me I need to go up on the y-axis 4 places and then plot my point. So a relation is multiple ordered pairs that are all grouped together. Here's what you need to know about a relation. Okay, you have what you know to be the domain, and then you also have a range. Okay, a domain and a range. A domain is your x value, a range is your y value. We also know this as input and output. Okay, you can think of these terms as nicknames. Okay, so we all have a real legal name, a name that's on your birth certificate. But a lot of us have nicknames too, right? Names that we go by, that we recognize as, you know, okay, they're calling my name, but it might not be my legal name. Well, that's what we're talking about here. The official name is a domain. Okay, the domain is the entire, all of the x values together. But we also know them to be x values, and we also call it an input. It's all basically the same thing. Same with range. All right, so a relation. In example 1, we have an example that they give us some information in a table. You have one of these on your homework where it gives you the information in a table. But we know, okay, it says the age in years is my x value, and my x value is 2. The length is my y value, my y value is 32. So what they do in the set of ordered pairs underneath is they pair these together to make ordered pairs. Do you see that? Okay, so you don't have to copy down the table, but you do need to copy down this set of ordered pairs underneath. And while you're copying that down, we're just going to kind of explain what's going on here. Imagine you're at an alligator farm, and this table represents 5 alligators that they have at their farm. Okay, well, is it possible for more than one alligator to be the same age? Yes. Absolutely. I mean, they lay eggs, and there can be multiple eggs in one single hatching. So yeah, they can definitely be, more than one can be the same age. So that's what you see here. There's a 2-year-old alligator, a 4-year-old, a 5-year-old, 2 5-year-olds, and a 7-year-old. And at these ages, their length is this specific measurement. At 2 years of age, this 2-year-old alligator is 32 inches long. These aren't averages, they're actual measurements of an alligator. So now what you're going to do is you're just going to identify the domain and the range of this relation. Remember, a relation, all that means is it's a set of ordered pairs that are all together. There are 5 sets of ordered pairs. All right, so domain is 2, 4, 5, and 7. A couple things about the domain that you need to know when you're listing domain. You do not have to write the repeated numbers twice, okay? You only have to write it once. So however you want to write that in your notes, just remind yourself, don't write the repeated numbers more than once, okay? So just because 5 is twice here doesn't mean I have to write it twice. I only have to write it once. The other thing is you have to write them in numerical order. So the lowest value up to the highest value needs to be in numerical order. All right, so now that's my domain. Now let's look at the range. Okay, so the smallest number in my range is 32. Then I go 59, 65. I'm not going to fit them all in, so I have to go down below 69 and 96. 96 is an 8-foot long alligator. I would not want to mess. Honestly, I wouldn't want to mess with any alligator, but especially an 8-foot long one. Okay, can you imagine an 8-foot long alligator? That's ridiculous. Okay, so so that's all you have to do on, let's see, 1, 2, 3 of your homework problems is just to identify the domain and range. Okay, so that's 3. That's a third, almost a third of your homework assignment. All right, so example 2, actually, let's do the checkpoint. Okay, so this is just a different relation. Okay, so a different set of ordered pairs. I want you to identify the domain and range. Remember, don't write your repeated numbers more than once, and then make sure they're least to greatest when you list them. Okay, so the domain, what's the smallest value in your domain? It's -3. Then what? -1. Now, I do see 2 -1s here, but that's okay. I'm only going to write it once. Okay, and then what? 6. All right, so I've listed my domain. What about my range? -1, 0, 2, and 4. All right, domain and range. Like I said, 3 problems like that on your homework tonight. So now we're going to look at 2 ways that we can represent a relation. What it means by representing a relation is we're just showing what it would look like if it were on a graph and if it were on a mapping diagram. So we're not solving anything, we're just showing the relation in a way that maybe is a little more easily readable, but we're not solving anything. All right, so there's 2 ways that we can do that. We can do it on a graph and we can do it on a mapping diagram. All right, so the first way, and I don't mind if you just do this on your regular paper, okay, but your homework needs to be on graph paper. Here, let me see. I want to use a color that's going to show up. Okay, so what I'm going to do is I need you to set up your XY coordinates. Remember, this is Y. The vertical one is Y, and the horizontal axis is X. And then you're going to number them. You only have to number every other, though. So it could be 2 and then 4, then 6 if you have room. -2, -4, -2, -4, and then 2 and 4. Okay, and then you just write your little dashes. All right, so here's my coordinate plane that I have set up. So you need to go ahead and just sketch one of these on your notes, please. All right, so now we're going to plot our points. We're going to follow the ordered pairs. I know it's been a while, so we might need a little bit of a review. But remember, let's look at the first pair, -1, or I'm sorry, 1, -1. So the first number is my x value. Since it's positive, I'm going to go which way on x, since it's positive? I'm going to go to the right 1. That's where my positives are, to the right. I'm going to go right 1, and then would I go up 1 or down 1? Down. I would go down 1. So I go right 1, down 1, and I plot my point. Okay? Now for the next one, where do I go? Right 2, up 0. Okay? And go ahead and do the rest of them. Go ahead and do the other 3. Plot those points. Okay, so the next one is over 3 up 1. Did you plot your point right about there? Yes. The next one is over 3 up 2. So we plot our point here. And then the next one is over 4 up 5. So it's right up here, right next to the top. And now what we've done is we've represented the relation on a graph. And you have 3 problems like this on your homework tonight, okay, where you need to do a graph of the relation, and then you're going to do a mapping diagram of the same relation. So in a mapping diagram, you have 2, we'll call them long ovals, okay? The first long oval is your input. The second long oval is your output. And we talked at the beginning of the lesson about the fact that the input and the output, that's the same thing as domain and range, right? That's the same thing as x and y. So we're going to pull all of our x values out of the relation. And again, we write them in numerical order, and we don't write the repeated inputs more than once. So underneath the input, what would be the first number that we would write? 1. What would be the second number? Well, no. Only inputs. 2. So we're only looking at our x values. 2. What would be the next input? 3. And what would be the next one? 4. We do not have to write the repeated numbers more than once. Okay? So there are 2 3s, but we're just going to write it one time. Now I want you to fill in your output values. Go ahead and fill those in. All right, so give me the outputs. Numerical order, it goes what?
-1, 0, 1, 2, 5.
Okay. And now that you've listed all your input and all your output, you're going to match them together to match the ordered pair that they came from. So in the ordered pair for the input 1, what was its matching output? -1. So you're going to draw an arrow. I'm trying to figure out what color I want to use. Can you see the purple?
Pink, yellow.
Yeah, yellow. Yellow is a good color. What about this? Can you see that better now? Okay, so we go from 1 to -1 because that matched up the ordered pair. All right, so for the next one, we went from 2 to what? 0. So we're going to draw our arrow over to 0. Go ahead and do the last 3. Draw the arrow from the input to the output that makes the ordered pair that was in the relation. Okay, so 3 to 1 and also 3 to 2. 4 to 5, okay? So what we see here is that the input 3 actually has 2 outputs, okay? And that's totally fine with a relation. A relation, no big deal. Let's imagine that this is alligators again, right? So we have 2 3-year-old alligators, and let's say one is a foot long and the other one is 2 feet long. Okay, well, maybe one of them just has a growth problem, right? Okay, so if it's a relation, that's fine. But what you're going to see upcoming, and what I would just want you to see while you're looking at this mapping diagram, is this is not a function, okay? So it's a relation, yes, but it's not a function, because if it's truly a function, this cannot exist right here. Every input has to have only one output. So the input 3 could have an output of 1 or 2, but it could not be both. All right? I just want you to kind of tuck that in the back of your mind as we go into the next example. Is everybody good on the graph and the mapping diagram? You have 3 problems on your homework tonight where you're going to graph the relation and put the relation on a mapping diagram, and that's going to be a big chunk of your homework grade. All right, so let's talk about functions, okay? Relations, okay, let me backtrack. A function is always a relation, and you can write that down. A function, that looks like a real good true-false question, is always a relation. Because remember, a relation is just a set of ordered pairs. That's all it is. That's the only criteria. It's just a set of ordered pairs together. But a relation is only sometimes a function. Just because it's a relation does not mean that it's a function. All right, because here's the criteria for a function. You need to write this down. If for each input there is exactly one output. Let's take, here, I'll write it on the screen. Let's take, for example, the function y equals x plus 2. Give me a value for x. And don't make it crazy, but give me a value for x. Wame? 5. Okay? So let's say I substitute in the function the value 5 for x. Okay? So here over here, I'm going to start my ordered pair. My x value is 5. What is 5 plus 2? 7. Can it be any other number?
No.
Okay? So here's what the function is saying. When you put 5 into the equation, the only value that can come out of it is 7. 5 plus 2 is not 8. 5 plus 2 is not 5. 5 plus 2 is 7. So for each input, now if I put a different input value in, am I going to get a different number out?
Yes.
If I put in a 3, I'm going to get a different number out. Okay? But if I put in a 5, the only number that's coming out of that is a 7. So that's the difference between a function and a relation. I kind of think of a relation as more real world. Okay, take 12-year-olds for example. Okay, well 13. Most of y'all are 13, 12 or 13 or even 14. Okay, well 14-year-olds, are they all the exact same height?
No.
No. Are they all the exact same weight?
Yes.
No. Okay. No. Everybody's different. So that's like real world. I think of relations as like real world examples, real life examples. Everything, just because you have one certain value doesn't mean the other one is going to be exactly the same. But when it comes to functions, it's different. Okay. So hopefully you can see the difference between them. Because in example 3, all you're doing is identifying whether or not a set of numbers is a function or not. And here's the kicker. All right, and write this down. If the input repeats, that's a red flag. If the input repeats, that's a red flag. You just need to look at the input values in the relation. If all the input values are different, then you don't have anything to worry about. The only time you have something to look at, if it's not a function, is if you have the same input value and it has different outputs. You can't have that. All right, so going back to the alligator example from example 1. These were the 5 alligators. You guys remember the 5 alligators? Okay, so one was 2, one was 4, 5, 5, and 7. Okay, well here's my red flag right here. Let me do it in white. Okay, I have an input that repeats. Everybody agree that 5 is the same input? So for every input, it can only have one output. So because 5 has an output of 65 and 69, it is not a function. It's a relation, no big deal. It's showing the relationship between the alligators, but it is not a function. And so here's what you would write on it, okay? And you can go back up to example 1 if you want, just so you don't have to rewrite it. But you're going to write, no, it is not a function because the input 5 has outputs of 65 and 69. So there has to be a reason. It's going to say, explain your reasoning. You can't just say yes or no. That's a flip of a coin. That's a guess. This right here tells me that you know why it's not a function. Because the input 5 has 2 outputs, and that cannot be. Okay? Now I want you to look at the second one and tell me, is it a function, yes or no, and why? Okay, what do you think, yes or no?
Yes. Yeah.
You say yes? Okay, so here's my checklist. I look at my inputs, 1, 2, 3, 4, 5. I don't even have to look at the outputs. I know that's a function. If I see an input repeat, it has to have the same output. No input repeats, I know it's a function. So I say yes, because each input has one output. And honestly, guys, anytime your answer is yes, that's going to be your reason. Anytime your answer is no, your reason is going to be telling me which input has multiple outputs. It'll be the same pattern every time for your reason. All right, so now example 4, we're looking at, let's say we don't have a set of ordered pairs, okay? Let's say we're looking at a graph and it says, is this relation, remember, it's all the points on the graph, so technically it's several ordered pairs, so it's a relation, but it's going to say, do these points represent a function? Does this graph represent a function? Well, you don't want to have to pull all the values out of it, okay? So the vertical line test is what can show you from a graph only if something is a function or not. All right, so here's our first graph that we're looking at, okay? The vertical line test says I can put a vertical line through every point on the graph and the line will only cross one point. So as long as, and you don't have to write this down, just kind of watch the screen. Do you agree that when I drew the line, you kind of can't see my line, let me make it red. When I draw my line right here, do you agree it only went through one point?
Yes.
Yeah, when I draw my line here, did it only go through one point? Yes, it only went through -1, -2. What about the other 3? If I drew a straight line through it, would it only pass through one point?
Yes.
Okay, so on your homework, you don't have to copy down the graph. You can just draw the straight line through the point, or mentally. Don't draw it in your book. Okay, which I wouldn't be surprised if there were some pencil marks on that question, but don't draw it in your book. Just kind of even draw it with your finger, okay? Does it pass through more than one point? If it does, then it's not a function. But for each one of these, I can clearly see that it only passes through one point. So yes, this is a function. Okay, you see that? Yes, it is a function. And so on your homework, on those questions, all you're going to say is yes or no. All right, now let me show you one that is not a function so you can see what you're looking for that would disqualify it. Do you see how this point on the far right, when they drew the line through that point, it actually intersected 2 points? Do you see that? So here's what this means. They had the same x value, but they had different y values. They had the same input, but they had different outputs, and that disqualifies it. Okay? So that's why the vertical line test works. Got it? All right, so that's everything you need to know for 8.1.